Dear colleagues, I have good news for everybody. The virtual tour is ready and is about to start. So I would suggest everybody to take in their places, yes, and enjoy virtual tour of Novovoronezh nuclear power plant.
Seven skies by this morning, and my mind on the run. Can't forget the love I'm feeling when I follow the sun. If you ever want my love again.
Okay, dear ladies and gentlemen, thanks again very much for your waiting. Welcome to Rosatom's virtual tour, and dear friends who are watching us online, you're welcome too. Today we are going to travel to Novovoronezh nuclear power plant to see its powerful, innovative 3+ generation VVER 1200 power unit. Our speaker for today is Valentina Povarova. She is a representative of Novovoronezh nuclear power plant. First, we are going to watch the virtual tour, and after that, we'll have some time to listen to your questions, ideas, comments, and etc. So, Valentina, please come here. I invite you on the stage.
Thank you, Anastasia. Good evening, everyone. And look what I brought today. What if I say it's 400 kilograms of coal or 2 barrels of oil? You may be surprised, but it is. This small fuel pellet weighs only 4 grams, but there is a huge energy hidden in it. So please turn off the light, and we are going to the nuclear power plant, Novovoronezh nuclear power plant virtual tour. There are several millions of such pellets are loaded onto in one reactor. And we have now 4 units in operation, so our total electrical capacity is more than 3,700 megawatts, and only two units, which you can see here, unit number 6 and number 7, have 2,400 megawatts of electrical capacity. During our tour today, we will learn operation principle of the plant main equipment and visit its key production facilities. We will visit main control room, then reactor hall during plant maintenance. Actually, we usually never take visitors there during real tour. And then we will go to the turbine hall, as well as see how our personnel are trained. So we are ready to start from the viewing point. We are moving there. Oh, okay, you have an opportunity to watch again. Just a few seconds. Okay, we are going to the viewing point where you can see all power units at our site, from unit number 1 to our modern units number 6 and 7. This plant, Novovoronezh power plant, is the first power plant in Russia with VVER pressurized water reactors. It plays a special role in the history of nuclear industry because here all reference units with VVER type of reactors were commissioned. Moreover, it is here all innovative solutions for power unit with VVR type of reactors were tested during construction, operation, modernization, and then decommissioning. Okay, great. Now we see the timeline. So you can discover that our unit number 1 was commissioned in September 1964. This is the starting point of our successful history of operating power units with VVR reactors. And now 7 units were built at our site. All power units in operation are the pilot one for serial reactors, VVR 440, VVR 1000, and VVR 1200. The total operating capacity, the total operating experience of our units is more than 180 years. And during all this time, our plant was a testing site for new approaches and technologies. Thus, for the first time in the history of nuclear industry, we carried out the thermal electric annealing of the reactor vessel. And now you can see the process. For unit number 3 and number 4 was extended, their lifetime was extended for 15 years. And after the second modernization of unit number 4, its service life was extended again from 30 years to 60. Just imagine, from 30 to 60 years. Is it okay? So, we returned again to the viewing point, and now let's focus on our 2 state-of-the-art units 6 and number 7. We are really proud of them because they belong to the last generation 3+. That means they are based on the latest technologies which fully complies all post-Fukushima safety requirements. And now we can see the building there they are located. The building with a domed roof is the reactor building. And please pay attention to the construction of pipes, which look like a large octopus. Later, I will tell you what the system is and its purpose. And moving a bit, and we can see the turbine hall, where the turbine itself and secondary circuit equipment and generator are located. So we have already seen our nuclear unit from outside, and now it's time to go inside. I invite you to go to the main control room. Just in a few seconds, we will be there. 2, 1, 0. Yes, here we are at the main control room. We can make a look just there. Okay, thank you. It's the brain of nuclear power plant. All information about operation of the reactor and other equipment comes here. And from here, all nuclear power plant's processes is carried out remotely. To understand the scope of the work at the main control room, let's have a closer look to the shared view screen, this big plasma exactly at the center of the room. Shared view screen receives about 200,000 of signals from all the equipment, reactor, turbine, and safety systems. Control parameters are displayed in real time. Temperature, vibration, the position of control rods, flow rates, a huge amount of information. Actually, every time I get there, I feel like in the pilot's cabin. A lot of monitors, sensors, switchers, signals, lights. But this crew, consisting of 5 persons, can read all this information easily. They are called operational personnel, and they bear a huge responsibility for the safe and reliable operation of power unit. And like a pilots, they have to get a license from the regulator to be allowed to operate the power unit. Let's get a closer look. On the left, we can see a senior engineer for reactor control. He is in charge for safe and reliable operation of the reactor. And in addition, he monitors the reactor neutronics and safety system. Close to him is the reactor department shift supervisor. He manages the shift personnel of the reactor department and controls the operation of the reactor department equipment. On the right is the senior engineer for turbine control. He is responsible for operation of the turbine, generator, and that's it. And the entire process, as well as shift crew actions, are controlled by one person. We are calling him unit shift supervisor. You can see his workplace here. He can watch and observe the whole main control room. During our real excursions, we usually asked, especially by young people and students, okay, how to become a unit shift supervisor? So it's not an easy way. First of all, you have to work for at least 3 years as a field operator. Then, after training for a year for the position of a senior engineer and passing all exams at the NPP, you need to obtain and get a license from the regulator. And only after that you will be allowed to work at the main control room. Thus, it would take at least 4 or 5 years to be allowed to work at the main control room, and at least 10 years to become a unit shift supervisor. I know it's challenging. Actually, my husband worked as a unit shift supervisor, so I know he went through all these career stages. He was training a lot, but he's still in training, in continuous training. So now you know how nuclear control room looks like. We can move to our next point, to the reactor hall, where reactor itself, the heart of nuclear power plant, is situated. Just some seconds. Oh, here we are at the reactor hall with the reactor VVR 1200. And you know, actually, during our tour, we have a unique opportunity to get into the reactor hall and even to stand close to the reactor VVR 1200. Because during real excursions, we never take visitors there, and people rarely present here during the operation of the power unit. It is simply not necessary, because there are a lot of sensors and cameras under the containment. They quickly determine the situation. And as I said before, everything, all equipment is controlled remotely from the MCR main control room. I have been working for 7 years at the plant, but I have been there only once, actually for making this video. Safety in the VVR reactors is based on the defense in-depth principle. This system consists of 4 physical barriers which are needed to prevent the release of radioactive substances. The first barrier is the durability of uranium fuel pellet, exactly the one I've showed you at the beginning. The second barrier is the sealed shell of the uranium fuel element. Then, such elements are loaded, are assembled into fuel assemblies, and 163 such assemblies are loaded into the reactor core. The third barrier is the 20 centimeters thick steel reactor vessel and the primary circuit. They prevent the release of fission products outside the containment, into containment. And the fourth barrier is the concrete seal containment itself. The sealing system, therefore, totally prevents the release of radioactive substances outside the containment. And we can, we returned to the reactor hall, and we can see a transport gate. Transport gate is a cylindrical chamber, hermetically sealed on both sides. During the preventive maintenance and reloading, cargo is delivered through the gateway exactly to the reactor hall. But even during this operation, the integrity of the compartment, the protection of the plant personnel, and the environmental protection is ensured. Now please look up, and we can see a polar crane. We can easily recognize it by yellow color. Okay, we can even see its rotation. It is needed for transporting cargo anywhere inside the reactor hall, of course. And it's also using during maintenance for transporting large-scale equipment and for transporting fuel. Fuel assemblies which are loaded into the reactor core should be replaced periodically. For such a replacement, we use a special robotic complex, a reloading machine. Then, uploading assemblies are loaded into a special place. It is called spent fuel pool, and it is needed for residual heat removal of our assemblies. Safety in the VVR reactors. It was almost about equipment, and now we can go to talk about safety systems. Our design combines active and passive safety systems. This ensures heat removal from the reactor core within 24 hours without any automated systems actuation. And one passive system we can see here. It is a sprinkler system. Under normal operation conditions, it looks like this, nothing special. But this system is triggered automatically when the pressure or temperature under the containment. Please just back a bit. I didn't stop. Okay, thank you. Again, about sprinkler system. This system is triggered automatically when the temperature or pressure under the containment increases. In this case, cold water is sprayed, the steam condenses, thereby reducing the temperature or pressure under the containment. Okay, we can move further. Help me, Anastasia. So, do you remember something looking like an octopus? It's time to reveal its purpose. It's the heat removal system consisting of 8 air delivery pipes. These systems is needed for heat removal from the reactor core in case of a power supply loss. And again, it is the passive systems. It works without automatics and no magic. It's just the law of physics. It looks impressive, I think. And one more passive system is the emergency core cooling system. It consists of 12 tanks. We can see them around the reactor hole. They are surrounding the reactor hole. So there are 12 tanks filled with a boric acid water solution. You may ask what they are intended for. In case of emergency, when the pressure in the primary socket falls below a certain value, the liquid is spilling to the reactor passively again, and the core is cooled. We can just have a look around. And we can go to turbine hole. I know it was a lot of information. Later will be a little bit easier, I promise. Sorry, we still missed one thing. A very important thing, I'm really sorry, because it's a core catcher. It has a unique equipment which was designed by Russian scientists to ensure the new level of safety. Under the most improbable, fantastic situation with the core melt, it will retain the fuel inside their containment. And for sure it was the last one. And now we are going to the turbine hole. At the turbine hole, we will see, okay, we are here, and we see the turbine installation with turbo generator. So some words about how everything works here. Steam produced into a steam generator, supplied here, and rotates the turbine. The turbine is designed to convert the kinetical energy of steam into the energy of the rotating of the turbine rotor. Then turbine rotor is connected to an electrical generator. So the mechanical energy is finally converted into electrical energy. Congratulations, we got electricity. Actually, I didn't mention about it, so maybe somebody can guess how fast does our turbine, So can you guess what is the rated speed of the turbine rotation? Please, any guesses? Who are ready to be the first? No guesses? Come on, just give me any scores. 5,000? 5,000? Oh my God, it's too... How much?
50 rotations
Per second, 50, different scores. Okay, I will answer by myself.
3,000 per minute.
Great, 3,000 rotates per minute. I see an expert here. Thank you so much. You are absolutely right. It's 3,000 rotates per minute. As a comparison, my washing machine at home has maximum 1,500, I think. So it's twice slower than our turbine. And yours? No, I don't ask anybody about machines. We are going to our next point. So we have an electricity. What's next? And we will learn about an electrical equipment at switchgear. We are near the switchgear. It is needed to distribute the electricity which is generated by power plant. Here you can see a closed type of switchgear. It was designed and made for the first time at our unit number 6. Before we have an open type devices. This type of switchgear is distinguished by high reliability and safety in service. One more advantage is its compactness. The area which is occupying by these switchgears are several times smaller than open type devices. And we are at the central electrical control room where our dispatching service operators continuously monitoring the generation and its distribution to different power lines. In our words, it is a place where we are transferring the electricity to different consumers, industrial ones, households, and so on. Moving further, and we are going to our next points, cooling towers and spray ponds. Okay, here we are. We find ourselves near two giant structures. These are two cooling towers for Unit 6 and for Unit 7. The height of each cooling tower is more than 171 meters. And nowadays, they are the highest cooling towers in Russia. As for me, they are really impressive. Okay, they are not so high as, for example, the sail of Burj Al Arab, only twice of it, but they are not made to impress anybody. Their only one purpose is to cooling the main equipment of the power plant. The service life of our cooling tower is up to 100 years. And now we are near the spray cooling ponds. We can just have a look. Okay, stop here, please. If you think that there are just fountains which were built to impress anybody or for delight of our personnel and visitors, sorry, but you are wrong. They are needed for heat removal from the plant main equipment. In other words, again, for cooling our main equipment. But they really look nice, and during hot summer, it is quite great to go through and spraying a bit to get some fresh there. Now, we have already seen almost main objects at the reactor plant, and now I invite you to go to the training center. Our training center is situated at the town. You can see our plant somewhere on the horizon, and here is the training center at one of the part of our town. Training center is designed for primary training of our personnel, and it also training on maintaining and improving our personnel skills. It is equipped with modern simulator prototypes of an existing equipment, and also it is equipped with a fully scale simulator. When we will come here inside, we will see it. Could we go inside? Okay, here we are. We are near the full scale simulator. Full simulator means that all buttons, all switches, and all monitors are located exactly at the same way as on a main control room. But of course, the real equipment is replaced by a software model, so it allowed to practice various scenarios for our personnel. It may be normal conditions, normal modes, also some violations of normal operation, and also severe accidents. And now you can see the video from the training of our personnel according to Fukushima accident scenario. Just some seconds to see. Please be sure he knows which button to press. During such trainings, our personnel also work out the team actions because they need to work as a single organism. And since 2016, this full-scale simulator also used for training foreign personnel at foreign power plants at foreign power plants which are carried out by Rosatom abroad. Now I invite you to go to Novovoronezh, the hometown for our personnel. It will be inside. Okay, we are at Novovoronezh. It is young and small town. It was built together with a power plant. Nowadays, 4,000 people provides an electricity to more than 2.5 million residents of our region. We at Rosatom follows sustainable development goals, and we provide sustainable economical growth, social improvements, and environmental protection. As I said, there is a small town, but thanks to Rosatom, we have different social and sports facilities. Now you can see our cinema. This is the color and music unique fountain. It was a present by Rosatom for our town. This is the ice arena, and we also have stadiums, modern swimming pools, and so on. Our citizens feel and appreciate such changes. Maybe that's why, according to the last survey, 60% of citizens of our region trust and support nuclear industry. And in our town, this score is even high, 80%. My family lives in near nuclear power plant for dozens of years. Some of my relatives work at NPP, and we are sure in environmental safety and in our future. Because we know that nuclear power plant provides a zero carbon dioxide emission. So, each such fuel pellet is our way to our goal. The goal for global zero carbon dioxide emission and to clean energy available to everyone. Thanks for your attention, you so attentive listeners. Our virtual tour is over.
Thank you, Valentina. I'm sure I would express opinion of many of our attendees today that virtual tour is more impressive when it is done not only very professionally, but also very gracefully, as demonstrated by you.
Thank you for compliment.
Yes, Valentina, thank you very much for your exciting presentation. Actually, I felt like I'm really there at Novovoronezh nuclear power plant. I hope that you... Guys, thank you. I actually hope that you felt it too. And now we are ready to your questions, maybe ideas or thoughts about our virtual tour, about Novovoronezh nuclear power plant. But before we start, we had online watchers, visitors. Valentina, there is a small question I would like to ask here. What is the difference? Why do you need two types of cooling equipment? I mean cooling towers and spray ponds.
Okay.
Are they the same?
Okay, I will answer this question. Somebody was really attentive listener during online session. So yes, we have two equipments, cooling towers and the spray ponds. As I said, they both need for cooling, but the difference is that cooling towers needed to bind condensers, and we mostly use water from the River Don, our regional river, to cooling this equipment, while spray cooling ponds are used mostly for cooling the reactor equipment, main equipment, yes, right, main equipment, and they differ with water, because at spray cooling cones, we usually used desalinating water, specially prepared. So that's the difference. And moreover, it is connected with the safety. We need to defarm according to the design.
Okay, thank you very much. Dear friends, now you can ask your questions. Please raise your hands. You will be given the microphone. If it's possible, please introduce yourself and let's have a small chat.
I feel it was very self-explanatory.
Okay.
Everybody tired? I think.
Yes, it's kind of a long journey, I understand. So again, thank you very much for your attention. Thank you very much that you've been here today with us. And actually, I would like to invite you to our next virtual tour on 21st of January. We will have a virtual tour at floating nuclear power plant. You know, the unique power plant, the only one floating power plant in the world. So again, thank you very much. The virtual tour is over.
Anastasia have already invited you to virtual tour, but
Yeah.
from my part, I would like to invite you to our real tour when pandemic situation will allow it. Thank you again.
So from my side, I would like to thank everybody who took part in our session of today. I hope it was both informative and useful for everybody. And of course, we would welcome your participation in other sessions of Rosatom Week in the frame of Dubai Expo 2020. Thank you very much.